We know that email service providers like Gmail and Yahoo sell our data to third-party companies for their usage. Quite often do we communicate exceedingly confidential information via email that we want only us and the recipient to know. So, can we do things with our own panache to keep our information as confidential as possible? We have techniques like steganography, encryption, and cryptography that can be used to keep our data confidential. But a combination of these techniques would help us keep our data highly confidential.
Hello everyone, this is Team Alekhya.
And our topic is enhancing security using digital image processing.
We chose to address the problem of security breaches using image processing. The paper that we used for reference was Enhancing Security Using Image Processing by Rahul Kumar, Ajit Pratap Singh, Arun Kumar Shukla and Rishabh Shukla. This research paper was published in International Journal of Innovative Research in Science, Engineering and Technology in 2015. The techniques used in this project include image steganography and encryption. Image steganography is a technique of hiding the data within the image in such a way that prevents the unintended user from detection of the hidden messages or data. Encryption is the process of making a message unintelligible, whereas steganography attempts to hide the existence of communication. Security can be provided to any image which is to be sent over the network or transferred using any electronic mode using image stitching and image steganography. A secret message and a secret image are the components that are to be sent across. The first phase in achieving this is the encrypting phase, which deals with the process of converting the secret image into a cipher image using the AES algorithm. We first resize the given image to a known size and then we divide the image into n x 16 blocks. The sender and receiver use a 128-bit key. This key is used for encryption and decryption of images. The key is represented as blocks, where each block is 8 bits long. Encryption is done in spans, where we process 16 pixels in each span, for both its cipher and inverse cipher. The ES algorithm uses a round function that is composed of 4 different byte-oriented transformations: subbytes, shift rows, mix columns, and add round key. In the subbyte step, each value in the state matrix is replaced with a subbyte using an 8-bit substitution box. The S box is constructed by combining the inverse function with an invertible affine transformation. In shift row step, we cyclically shift the bytes in each row by a certain offset. The first row is left unchanged. Each byte of the second row is shifted 1 to the left. Similarly, the third and fourth rows are shifted by offsets of 2 and 3 respectively. In the third step, which is mixed column step, the 4 bytes of each column of the state are combined using an invertible linear transformation like multiplication followed by bitwise XOR. In the add round key step, the subkey is combined with the state. For each round, a subkey is derived from the main key. The subkey is added by combining each byte of the state with the corresponding byte of the subkey using bitwise XOR.
After encrypting the secret image, least significant bit-based image steganography is performed to hide the secret text in the secret image. We append a null character with the secret text to denote the end of text. This text is now hidden in the secret image. The secret text is converted into its ASCII representation. These ASCII values are converted into the 8-bit binary representation. The least significant bits of the pixel values of the secret image are replaced with these bits in order. Hence, the secret text is successfully hidden inside the secret image. LSB-based image steganography involves hiding data in the least significant bits of an image as it contains the least amount of information, and flipping them will not cause a considerable change to the appearance of the image. Now, this encrypted secret image containing the secret text is hidden in a cover image, again using LSB-based image steganography. The binary representation of the pixel values of the encrypted image with the secret text in it is hidden first in the red component, followed by the blue and the green components.
Next, we divide the cover image with the cipher image and the secret text embedded in it into multiple parts. Each part is then separately sent to the recipient. On the receiver's end, the sub-images are stitched back to regain the original image. The least significant bits of the red, blue, and the green components are extracted 8 bits at a time for the entire size of the secret image. Now, we obtain a cipher image with the secret text embedded in it. From this image, the least significant bits are extorted 8 bits at a time until we hit a number representing a 0. These 8-bit binary numbers obtained are converted to their decimal representation. These decimal representations represent the ASCII values of the characters. They are then converted back to their character form to obtain the secret message. The cipher image is decrypted using AES decryption. The steps performed during AES encryption are now performed in reverse order. Hence, we first undo the add round key step followed by inverting mixed columns. We then revert back the shifted rows and then finally perform inverse subbyte substitution. In the inverse subbyte step, we first take the inverse of the affine transformation and then find the multiplicative inverse. At the end of this process, we obtain back the secret image. Hence, we have successfully shifted the secret message and the secret image to the recipient in plain sight. The contribution of each team member are as follows. Hemkesh V. Kumar coded the algorithm for image stitching and segmentation and also for the recovery of secret text from the Stego image. Jeevan Nagraj coded the embedding of secret image into the cover image and also for the extraction of the same. He also coded for the embedding of secret text into the secret image. Manoj S. Hegde was responsible for the development of the entire module of AES encryption and decryption. All team members equally took part in meetings and in decision making.